Okay, we are live.
Thanks, Bill. Thanks everyone for joining the office hours for Layer7 in April. Apologies for the late invite going out. We had a few technical issues internally. I think that should be sorted from now on. We are recording this, so it will be available as a replay. And the topic this month is we have Sean O'Connell from Dublin, Ireland joining us. He's one of our senior API consultants at Broadcom, been working with Layer7 a long time, and he's going to look at using the MAG capability and the API that we have within MAG to build an app, but in a maybe a more powerful way. So he's going to build one application and then show you how we can use that on multiple platforms and how powerful that can be. So I don't think I've oversold or undersold there, Sean. So if you want to give another intro, that's great, and we'll hand over to you.
Okay, great. Thanks, Aaron. Let me just kick off here with a quick introduction around what MAG is and what's available already on the GitHub community. So as a user of Layer7, you'll be aware of the Layer7 community. There's a GitHub repository in there where we put in some sample policies, some sample projects, and one part of that is a mobile section. In there, there's sample dedicated apps for using the SDK, the MAG SDK for iOS and Android. So it basically shows the functionality that a mobile app can use to interact with the MAG server. What does the MAG server actually bring you? It allows you to register a app securely with the API gateway, things like mutual SSL authentication using device identifiers, etc., such that a man-in-the-middle attack is almost impossible when it comes to interacting from the mobile app to the MAG server itself. It allows you to employ things like geofencing, SSL pinning, so that I'm guaranteed I'm only talking to the MAG server. It allows for the scenario that somebody takes a mobile app when it's published to the Play Store or the Apple Store or one of the other equivalent stores out there. It allows for the fact that somebody can deobfuscate the code, reverse engineer the mobile app, which happens very, very regularly, and steal any embedded secrets that would be in a mobile app. So we work on the basis that there won't be any embedded secrets in the app itself, except for a configuration file that you get from the MAG server. So there's a lot of bang for buck in the MAG server, and we provide with that MAG server capability is an SDK. One of the things we have with the SDK, one of the challenges is that it's constantly the operating systems on which it works with predominantly iOS and Android. It's constantly evolving, constantly changing, etc., and new features are being added every time there's a new release. And some customers have been asking us, look, how do I build a mobile app to talk to the MAG server without the need for the MAG SDK? Is it possible? And yes, it is. So we embarked on a project about 7 months ago. Aaron rang me up and said, could we build some sample Android and iOS apps without using the SDK, which we published under this link up here. The drawback of those projects is that they are developed in Java or Swift, depending on the operating system, whether it's Mac or whether it's Android. So you have to know specific stuff around Java and asynchronous coding for Swift, etc. So there's a bit of deep dive involved in that. Then the next challenge that came along is, can I develop a code base, an app, using a single code base that will run on Android or run on iOS, or could run on Mac OS or Chrome or Firebase, without actually having to make a code change? So this is one of the things I embarked upon about 3 or 4 months ago to see how we would do about this. And there's different development frameworks out there that you could look to use, including Ionic and Cordova, but they tend to be interpretive type frameworks, and they don't give you the final level of control when you want to get low level into the actual device, especially into the look and feel of an app or to device properties such as its GPS chip the accelerometer, face ID recognition, etc., etc. So we came across the idea of using Google Flutter and Dart. This is one of the more newer frameworks that allows you to write the code or your app once, integrate it with your downstream system, in this case the Mag server, and run it where you want to run it. So it's quite a powerful capability to develop it once and run it wherever you want to run it effectively. In case you're not aware of, this is where you will find all the code that I will touch upon, some of the code and projects that has been developed using Google Flutter in this presentation. But in case you're looking for it itself, it is published on GitHub in underneath the non-Mag SDK sample apps. If you still want to use also the Mag SDK, there are sample ones that are up to date for Android and iOS in the top the higher up directory. But inside the actual non-Mag SDK sample apps, there's a new folder called Mag Flutter sample app itself. And that allows you to do the full handshake, which is a 3-stage handshake with the Mag server to actually get an access token, from which then you can access protected APIs on the Mag server, which are protected using mutual SSL and the access token that is acquired during the handshake with the Mag server by the mobile app itself. I'm not going to spend too much time at PowerPoint. I am going to drop straight into Visual Studio. It's what you typically develop sample apps for on Google Flutter. But it's based upon using VS Studio and Google Flutter frameworks and Dart programming language. It takes a bit of getting used to, but I would say a matter of probably about a week to on board with it, because different paradigms and different ways of presenting the stuff, etc. But it is possible to write a single code base that will run on Android, iOS, Mac, Chrome, etc. The only thing you need to be have to be aware of is that you need access wherever you're running the sample code base itself. You need to be aware that I need access to secure storage. So Android, obviously, and iOS at the keychain are shared preferences on Android, but Chrome has only recently come out with secure storage capability built into it. Firebase has its own equivalent. And if you don't have access to secure storage, then the Mag handshake is quite limited. Why do we need secure storage? I mentioned at the very beginning we use mutual SSL authentication. We use an access token. You don't want to leave them floating around on the operating system itself, so especially when the device is turned off, etc. So you want to have secure storage, which are built into the operating system on those type of devices. So if they have access to those, and also is the ability to have pick the location of the device using its onboard GPS chip, then happy days with using the likes of Google Flutter for developing these type of apps. My personal advantage of using this frameworks is that having done it on Java for Android and iOS with Swift, MTLS and mutual TLS and API invocation is actually very easy. I found that trying to do mutual TLS with pinning of the server-side certificate is complicated and tricky. What do I mean by that? So I also mentioned at the beginning is man-in-the-middle attacks. So when you go to the Mag server, you say, give me a configuration for my app. And in there is the Mag server certificate. So when you do your 3-step handshake with the Mag server, when you start up the mobile app, it will say, okay, am I talking to a real Mag server that I'm registered with? And you can check with the certificate you got in the configuration file called the MSO config file. Is that the one that's actually been presented in the SSL session, or is actually somebody trying to impersonate it? And if they are, then I can throw away that session and know something is wrong. And that's really important to know who you're talking to. Not only am I talking to the right Mag server instance, but at the same time it needs to know that it is talking to the right app that has been authorized to use the MAG server. And this is what is built into the MAG capability of the API gateway. In the sample app itself, there's a full the full handshake for a MAG protocol is provided in a stepwise stage, so it's very easy to understand. All the debugging information to see is provided. What do I mean by the MAG protocol? Just to give a brief recap on it. It's 3 stages, so it's not going to it's not complicated to actually understand what it's doing. But typically, when you get a register with your app into the MAG console, there's a management console with the MAG capability of the Layer7 gateway. It will you will get a master key. A master key says Sean's apps from acme.com have a master key. What that you do is you exchange that with the MAG server and say, give me back a client ID and a client secret for my instance of my app. So even if somebody steals my app, deobfuscates, reverse engineers the code, all they're going to get is a master client ID. They will never get my client ID or client secret. These are dynamically generated with a certain expiry lifetime on them. What that gives back to me now is I have a client ID and a client secret. I then look to create my own private key, an RSA private key. You can decide on the size of the key you want to have, depending on security levels. But then you can say, okay, I have a client ID, client secret. I need to go and get an ID token and a MAG identifier for my instance of my app. And you can decide whether you want to have that private key shared with other instances of this app, other instances of apps from my organization. So you have single sign-on capability, or you want to keep it just within the scope of the current running mobile app. So in this case, then I'm now going to register the app. I've got a client ID, client secret. I'm going to call the register endpoint on the MAG server, and I'm going to give in a device identifier, which is just a random value. Device name, this is important because I want to be able to self-manage there afterwards my mobile instance of my app in my mobile device using the MAG console. And you'll see this in a few minutes what I actually mean there. But it's important to have the device name. You'll see it in the emulator that'll come up as iPhone 13. It'll come up as my Mac device itself. Authorization, it's my client ID, client secret, and the user credentials of the username and password, or it could be something else, as well as a self-generated private certificate request that's payment coded to be sent to the MAG server. What will come back is an ID token for that user, the scope of the ID token, and in the body of the response is going to be an encoded certificate, which is signed by the MAG server itself. So I will only allow any request coming into the MAG server if it's using a certificate that it has issued and associated with a particular MAG identifier, so it knows, okay, that's a valid session that's coming in. Without any of that information being provided, we don't allow any requests coming into the MAG server. So it's quite starting to tighten up on the interactions on the SSL session. What about the user session? Well, I have an ID token, which says, give me information about the user. I surrender the ID token in the final stage. You'll be happy to hear. I surrender the ID token in the form of a getting back an access token. So in the assertion field is the actual ID token that's sent over to the MAG server, to the token endpoint on the MAG server, a member of the OTK, and I get back an access token as well as a refresh token, which has a defined scope and expiry time. Once that's all done, I'm now ready to access the protected endpoint. To access a protected endpoint, I send over the access token I got by surrendering the ID token. I send over the exert if the MAG server is going through a proxy, an outer proxy, then I might want to send over my client-side certificate I received in the handshake, because sometimes you find that proxies actually will not pass on. If I'm coming on a mutual SSL sessions, it may not pass on the client certificate into the MAG server itself. So we have the option of providing it in a header. And then optionally geolocation. Where is that device? So I can do geofencing on the actual API request that's coming in. And then I get back my protected response code. Protected API data as a JSON response or whatever format is required. So it's not rocket science. It's a 4-stage process. You then have additional steps for refreshing the access token. I have a refresh access token. Can you give me a new one? In the sample app, we monitor, there's a thread that runs in the background that monitors expiry time of the access token. It's by default, it's 1 hour. And when that's about to expire, it requests a new access token in the mobile app automatically. And finally, that's putting it all together. I didn't think you'd appreciate me putting that up at the very beginning to say this is what actually happens in the handshake. You don't see this. It's very, very fast. So before I jump into the demo, just highlight a couple of little things. Can I still use the SDK? Absolutely. There's the latest version that was released there a few weeks back. The SDK docs are linked in this PowerPoint presentation. The whole aim of this talk and this field initiative was to offer additional freedoms. Build it once, run it where I would need to run it, Android, iOS, Mac, Chrome. Often, taking this type of native approach makes it easier to align with the latest OS versions that have been released. It is very difficult to keep up to date, especially in Android, with all the multitude of different versions of the OS that has been released on a constant basis, and with new bells and whistles, new behaviors, deprecation of APIs, deprecation of functionality in libraries, where this tends to be hidden away from you with Google Flutter and Dart itself. So let me jump into a quick demo. What I'm going to show you here, this switch it back, here we go. So what I'm going to show you here is 2 instances of the same app. Let's tidy up my desktop a little bit here. So I have, in this case, I have iOS running simultaneously on my Mac. Apologies if you hear a bit of spinning of my CPU as it's running quite hot at the moment, running these simulators side by side. But I could also have over here Chrome. I could also have Android running on the in the simulator, or I've run this on actual physical devices itself. So what I do is I go to log in, and I've logged in, and I get now access to a protected API. A non-protected API, which is also available with the SDK, is I just want to hit an endpoint. Whether that's hosted on the gateway or whether that's hosted somewhere out on the enterprise, on the internet, I don't really care. I just want to hit an unprotected API. So in this case, it's just hitting the gateway and getting its current timestamp back. When I go to hit a protected API, it's going through the handshake, as I said before, which is I have an access token now. I want to hit a protected endpoint. In this case, here's the access token, here's the excerpt, and please give me back a valid information. And I'm doing mutual SSL. It's very, very responsive using Google Flutter. Why is that? Unlike Ionic and Cordova and some of the other frameworks out there, it's compiled to the binary of the operating system. In this case, the Mac OS. It's hence why it's very, very fast. And you'll see that the very same, if I log out here and I log over here, this is a separate simulator. This is iOS iPhone 13 simulator. I log in here and I go and access, and you can see down here is that there's a countdown, a common thread that basically says you have an access token. I'm just going to count down. I'll auto refresh it in the background. Rather than just hiding it from the user, which we could easily do, we just put it up there in the front so you can see what is actually happening. And I'm accessing this protected data. If I go to Visual Studio, here, I can see that there's the client certificate. The response coming back from the gateway is saying to me, this is the client certificate that you sent over in the header. I pulled out the distinguished name in it, but you probably can't see that particularly well there. So if I go to the MAG console, the admin console that a lot of people will be familiar with, and do a list of the devices I currently have, I can see I have 2 devices registered for my name, or my user ID, in this case, Sean BOC. I can see that the certificate that was generated for me includes the device name, sorry. So it's an iPhone standard edition. It's a Mac OS. So I know there's 2 different types of applications that are using my particular MAG APIs from particular operating systems, etc. I can go in here and self-manage. I can turn off, deactivate them, and I can delete this device. So if I go and delete that device and try to use the API itself, it will not, use the app again with the MAG server, it will be blocked automatically, because as far as the MAG server is concerned, I don't know who that user is anymore. They've been deregistered from the system, their certificate has been deleted, and therefore I'm not going to honor any of their traffic requests coming in. And that's quite powerful. It just means is if I lose my device, if I have geolocation information coming through on the API request, I can say this is the last time it was seen. I want to deactivate it, or I can actually go recover that device itself using the MAG SDK and using the self-service front end. Again, this is a standard out of the box front end, but we've had other type of demonstrations where we show the location of the actual device and was last used to access those APIs. It could be a banking app, it could be any type of any type of related sensitive app that you want to be able to deactivate on the device, or you want to be able to delete off that particular device there afterwards. So there's quite a powerful range of features that are being provided just with this mobile app. What does the code look like for those who really want to get deep down into it? So I mentioned that there's 3 stages in the actual interaction. Let me bring up Visual Studio. It's typically how you build the mobile apps to interact with using Google Flutter with the MAG server. So stage 1 is I need to initialize the mobile app, and it looks complicated, but if you're doing this on Android or you're doing this on iOS, it's a lot more ugly and complicated. And to break this down is I'm calling to the initialize endpoint. And let me just see if we can zoom in here. It's bigger. I'm calling to initialize endpoint, which is I have a master ID for my app. I want a client ID, client secret specific for my instance. So I pull from a configuration file I get from the MAG server, the master ID, and I generate a device ID, which is just a random value that's specific to my instance of the app running on my mobile device. I then will create what they call a map, effectively is headers. What type of content type am I sending over? Here is the base64 encoded device identifier. And here's my master client ID that I'm sending over to the MAG server to say, give me back a specific client ID, client secret for this instance of the app. I also embellish the parameters being sent over with a nonce to prevent counteract message replay. That is all you really have to do with sending over the request. One important point I would put in and just highlight it here is called bad certificate callback. This is to do with SSL pinning. when I make a request, how do I know if that request is being answered by a valid MAG server? So in the configuration file I get from the MAG instance, it has the server public key certificate. If I get a response back in the HTTP handshake that has not aligned with that certificate, it immediately is identified as an invalid certificate presented by the MAG server. Somebody's impersonating, somebody's doing a man-in-the-middle attack and break the connection immediately. So this is, and to do that in Android and iOS is actually quite tricky. Where it's literally one line of code. When I found this brilliant, because it did take me several days to figure out with Android particularly, where it's just a one line of code with a Google Flutter. And then I issued the post request. Again, this is all asynchronous coding, and I wait for the response to come back. And the response comes back, there's my client ID, there's my client secret, and client expiration. So it's I found it very easy to code this up rapidly. It was more, I spent more time probably on the presentation than it actually did on interaction with the MAG server to get the responses and interact with APIs, etc. It was just trying to figure out how Flutter actually works, so I spent more time than in the API interactions. That's just stage one. Stage two, and I won't go through all the stages, but just to get you a feel for the power that this thing has. Stage two again is I'm generating I need to send over I'm generating a private key. I need to send over a certificate signing request, or CSR. Here I generate the RSA private key. I need to code up. Here I generate the CSR in PEM format. Again, doing this in Android and iOS is quite tricky. And once I have generated the CSR, is make it again the header request to the MAG server. In this case, this is the content type. This is device ID, which is the same as stage one request. The device name, which is also embedded into the certificate request. Is it an Android? Is it Sean's iPhone? Is it an emulator, etc.? And as well as the user credentials, the login ID, the username and password for the user, coupled with the client ID and secret for the app instance itself. So layers of security built into the MAG protocol that is hidden behind normally in the SDK, but you get to look at it in the raw format with the actual with doing this yourself with either natively in Android, iOS, or in this case Google Flutter. And once I have built up that payload, I just issue my I create the HTTP context request. Again, I check if there's a bad certificate going to be issued a response from the MAG server, and I then post that payload to the MAG server itself. So I know I'm only talking to that MAG server. I'm not talking to somebody impersonating it. The response that comes back to me gives me, if I get back a valid signed certificate, then I'm going to store the private key into secure storage. Again, back to my original point, is having access to secure storage is important on the mobile device, and it can be tricky to code that up, especially in the likes of Firebase or some of the other newer devices coming around. Google Flutter was able to hide a lot of this for me. I get back my ID token, which I will the next stage surrender that for an access token, the MAG identifier, which is issued by the MAG server, and I store them into secure storage on the actual device. Now, I don't know, because I'm coding in this higher level language, I don't know what that means from secure storage perspective, what it means to be storing it into the keychain, or shared preferences, encrypted shared preference on Android, or what's the equivalent on the Mac side of things, i.e. in this case, the keychain. I don't need to know about those details. Where you do need to be very much aware of it when you're doing this using Xcode or Android Studio, etc. And it can be tricky to get it right, where a lot of this is hidden from you. Thankfully, when you are doing it with this higher level programming framework, etc. I won't go into any deeper level details. The source code is there. One thing I will bring your attention is that you can see all the debugging information, the debugging console. If I bring up, where is simulator? No, Android simulator, this one. So I'm just going to deregister here. If I scroll down to the bottom here, I'm going to log in here again. So I'm going through, I've deregistered, so there's no certificate, there's nothing on the mobile app. So I'm putting in my username and password. And what you should see down here is the full handshake takes place it's not working at the moment because I've got two simulators running, but what you will see is that you'll see the full handshake going on. And this case is there's the certificate that's come back from the MAG server. I can see the client access token that comes back when I surrender with the ID token, the expiry time, the refresh token. You get to see all that information is built in and pushed out to the debug console, so you can see exactly how the protocol is actually working, and as well as how to do automatic refreshing of the access token. I've had this running for 24 hours, no problems. It just automatically refreshes the access token in the background, so that you can constantly just be hitting the protected API. The sample policies, etc., are standard MAG policies that provide with the actual solution kit. It's a protected API that's protected that requires an access token and mutual SSL coming in to the MAG server itself. And unless you have a valid access token with a valid MAG identifier and a client certificate that is signed by the MAG server, then you're not getting into that protected API itself. So it's quite in-depth and capable what the MAG server is doing for you. And then you can see all the details from this native app that's been built and runs on different platform itself. Jumping back just to, that's a quick run through of the demo. You can obviously continue to use the SDK. The SDK itself provides things like single sign-on, which you'd have to code into this environment, into your app yourself. But single sign-on effectively is based upon sharing of keychains or encrypted share preferences on Android. And therefore it's an access token that you want to share between instances of different apps. The things like Face ID is for authentication, etc., is also built into the likes of Google Flutter, and there's packages available for taking advantage of all those type of features within within those frameworks for each of the different types of devices. Some devices will have GPS chips, some won't, so you can actually make code changes or decisions at runtime when you need to, etc. So there's a lot of capabilities, but the aim here was provide one code base that allows you to run this app, run a MAG consuming app on whichever operating system you want. In this case, I'm running it from Mac, but I'm running it on Android, and it's quite agnostic to the different flavors of Android out there. When you're developing an Android specific app, you need to be actually cognizant of older versions of Android, because therefore, where do I store my private key? The encrypted shared preferences capability is not available in older versions of Android. And some of the behaviors of the Android OS change as you naturally expect as you get through to newer versions, etc. And there are thousands of different variants of the Android OS out there. So I found coding this up very straightforward, very fast, without having to be spending too much time worrying about the underlying platforms that this has been run on. So let me just pause there and check if there's any questions. Was this useful for anybody?
And it really useful, Sean, for myself, but see if there's any. I have a quick question actually, Sean. So what you've done here is just access the standard mag services that get installed with a mag install, right? You've not changed or created any new endpoints.
Nope. So the emphasis here was to use standard out of the box, without adding to it and without having to do some magic sleight of hand. And at the same time, is a lot of customers ask us, how does the MAG protocol work? What value does it give me? Is it secure? Well, we're providing all the details on how the MAG protocol works, and you can see exactly how the security actually works. Everything from SSL pinning, use of access tokens, use of the ID token, the use of private keys, so that you can confirm that I am only talking to the MAC server, and the MAC server confirms I'm only talking to that app. At the same time, is we're allowing for the fact is that somebody is going to just take the app and access any sensitive information in it when it's pulled down from the Play Store, etc. So all you're going to get is a master key, but you're not going to be able to get access to the instance data of that app, which in this case would be a client secret client ID.
Right. Cool. Any questions from anybody else on the call?
I have a question for you guys. So I joined the meeting a little late, but are we going over the Google Flutter platform or framework to be able to use or integrate with MAG and spit out the code for or integrate with the other frameworks like Xamarin or Cordova or other ones?
So the focus here was to look. So what you have here is a Google Flutter environment, which is coded in Flutter/Dart. The other frameworks like Xamarin or Cordova are separately available. I believe that the Xamarin's SDK has been deprecated or is to be deprecated. But the focus of this presentation is on the Google Flutter. So you can go to the, let me just go to here. You can go to the community and pull down this app, run it up in Visual Studio, configure in Flutter, which takes about 5 minutes. And you can literally pull this down from GitHub and run it to access your MAG server. In this case, actually, there is a hosted MAG gateway running on GCP. So I know that some people have taken it already and ran it and said it's working. Why is it working? Because it's talking to our MAG server. And the reason why it's talking to our MAG server, I talked about SSL pinning, is you get this configuration file from the MAG administration console called MSO config file. It's specific to your registered app or your organization. That is the server certificate. So I can confirm I'm definitely getting a response from, I'm definitely talking to the MAG server. I'm not talking to somebody who's trying to impersonate it. And in there is also the, where is it, the master, where's it got, oh yes, client ID. That's it, that's the master client ID that is used for all for all instances of the actual app, but there's a specific client secret that's created for this app when it's actually run and integrated with the MAG server itself. So this is kind of the blueprint that says this is how you talk to the MAG server, but using this certificate, using this master key, but then we'll give you a specific client ID, client secret for your instance for interacting with the MAG server there afterwards.
Okay. So okay. I think I'm clear. Yep.
So we're focusing just on Google Flutter in this presentation. If you want to have a Android, there's an Android specific project there. There's an iOS specific project there as well. And you will see that there's a dramatic difference in the complexity of the code when you switch between this particular project and Android or iOS.
Yeah.
Especially when it comes to things like trusting SSL certificates and sessions.
Yeah, we have, and we also plan to implement the certificate pinning outside of this new framework. So that's we've been doing for a while. So
Okay. And you may say there's samples for doing SSL pinning if in both projects as well, so you can lift the sample code there to use.
thank you.
And again, I hope I pronounced your name reasonably close, but just as a reference, this is being recorded and we will put that up on the Broadcom community site within the next couple of days. So, if you want to go back and watch the start and Sean's explanation and intro, then feel free to do that.
Sure. Thanks, Eric. Yeah.
Problem. Okay. Any other questions from anybody?
It looks like a really good explanation of the MAC protocol in itself.
Yeah.
I think might be one or two other additional things that might be engineered into a real app, but yeah, it's a great start. I mean, it's things like you start with the master client ID and you get that client ID and secret back that's instance specific, but that has a lifetime associated with it. I think it's like 10 days or something by default. So you might need something in there to refresh that every now and again. And also things like handling when the endpoint certificate actually changes or expires. How you manage that without requiring all your users to download a different app or re-register.
Yeah.
But yeah, it looks really interesting.
Yeah. Hi, David. Not spoken to you for ages. Yeah, I think what Sean's done here really well, and I think he did it so well that there aren't that many questions. This for me gives us two things. It gives people that visibility of just how powerful the services that run on the MAG are. And then maybe introducing Flutter is a great thing for people that are having to want to write once and deploy in many places. So I think that's that's a really good job by Sean. The SDK is really valuable, but what we found, I think to your point, David, is SDKs are great until you want to customize something or want to handle something a little bit differently. So the SDK, I think, is still really valuable and useful, but Sean's example here in Flutter and the two he's shared on GitHub for Android and iOS kind of break it down. So customers that want to go in a different route from the SDK actually have that, have that capability, and they can use these as great learning points. So, yep. Okay.
Yeah, I'm definitely going to download that and give that a try. And also, I believe you can call out to native code from Flutter anyway. So if there's something you can't do in Flutter, then that's always an option as well.
Yeah, cool.
Absolutely. And just to go back to the original point about the SSL pinning, to do this in Android is probably 10 lines of code. It's one line in Flutter. So it's just the difference, and that's what I'm highlighting here, is just SSL pinning. I'm only going to do an HTTP session if I get a good certificate, and here's my good certificate that I expect. Anything else, I just won't accept it. And it's also is to shed a light on the protocol, so people can see be below the deck of the SDK what it is actually doing and where the security is. Because a lot of times as app developers are more interested in just the presentation side of things rather than the security of where I'm getting data from. Okay.
Cool. Well, thanks, Sean. If there are no other questions, I'm just going to check the chat window.
While you're doing that, let me chime in. For those of you who might be interested, immediately following this session is the quarterly API Academy Tech Talk. And the subject today is going to be on API security, past, present, and future. And we're actually working with an interesting technology partner, No Name Security, who's going to be their CISO and CTO are both joining to chime in on the whole concept. For the invite, if you somehow missed the social media blitz that took place over the last 7 days, you can go to apiacademy.co and you can pull down the invite there. It's at the top right corner. With that, I'll go back to Aaron.
Yeah, I was just going to wrap up and hand over to you, Bill. So, I guess.
I have a question, guys, if you don't mind. Sean, in your presentation, like you had this Mac user and Mac user password. is this for specific use case you were trying to integrate with the login UI form, or were you trying to use, let's say, password grant type or something? I'm not sure.
It's just a registered user that I have on the Mag server itself. I'm using again, I wanted to keep it standard, so there's a user on the Mag server that you can create, or you can integrate with a downstream directory to authenticate the actual user. So I'm just literally using a standard registered user for the Mag server, but you can make it as more complicated or more real life as you need.
Okay, makes sense. Okay, thank you.
Yeah,
Okay.
those credentials can be anything. We're using card numbers and a token in the password field as an example. You just set up the identity provider at the other end.
So you can grab
Yeah.
this on the Mag server and make decisions. Oh, it is N of M authentication credentials. It's not a username and password. It's just a user ID and N of M token values. But yeah, and you have access to all those policies on the Mag server to make that access decision. We leave it there. Does that answer your question?
Yeah, this does answer my question. Thank you.
Like I said, once Bill presses stop on the record, it'll be uploaded to the communities in the next couple of days. If you've got any questions, you can come directly to us, or you can use the community site to start a conversation about this. And yeah, we look forward to your feedback and questions. Any help, let us know. Other than that, I just want to say a big thank you to Sean. I thought that was a great session, and you covered the topic so well that yeah, I think it will be a really good resource for anyone that missed it. And yeah, Bill, I guess you can stop the recording, and we thank everyone for joining.
I'm turning off now. Thank you again, everybody, for coming, and we'll see you again next month.